Hey class, this is Miss Wendt, and what I want to show you today is this lab activity, why most cells are small. Okay, and we have a warm-up to kind of get us started here. This activity is going to take a little bit of math. So in a regular classroom, we would actually take some boxes and take some rulers and find the surface area and volume of them. Okay, so we're just going to kind of simulate that with these pictures here in this classroom. So just to recap, how to find surface area. Area is length times width of any square, and we want to find the area of all the surfaces. So there's a top, a bottom, a left, a right, and a front and a back. Okay, so if I want to find the surface area of the front of the box, the length would be 10 across, and the width here would be 4. So it'd be 4 times 10 will give me the surface area of the front. Okay, so that's going to be this area here that I've got colored in red. Now the back of the box over here is going to be the same size. So for the back, I'm going to have another 4 times 10. Okay. Now, this side right here, if I want to find the area of this side, it's 3. And then I don't have another number here, but over here, this side was 4. So I know that this side over here, come on, 10. This side here would also be 4. So the right side of the box would be 4 times 3. And then over here we would have the left side of the box, which would also be 4 times 3. Okay. And then we have the top. Let's make the top blue. The top of the box, this long side here is 10. So the top of the box is 10, and then the short side right here, this angled side, is going to be the same as the angled side on the bottom, which was 3. So 10 times 3. And the bottom of the box is going to be exactly the same. Okay, so any box that has 6 sides, front, back, left and right, top and bottom. So if I multiply these numbers together, and then I need to add them up. Okay, so 4 times 10 is 40. Let's see, 4 times 3, that's 12. And then 10 times 3 would be 30. Okay, so I have the surface area of each side. Now, for total, I have to add them all up. So 40 plus 40 plus 12 plus 12 plus 30 plus 30. Now there are other ways to find surface area. I kind of did it this extended way just so you can see where all the numbers come from. Okay, and all together, if I add all these up, and calculators are fine, I get a total of 164, and my units were centimeters, and because I did all of these were centimeters times centimeters, centimeters squared is going to be my unit. Okay, so surface area is a little complicated to solve. Volume's a lot easier. Volume is going to be length times width times height. Okay, so I have 4 and 10 and 3. It doesn't matter what order you multiply them in. So 4 times 10 times 3, that is going to give me 120. And because this was centimeters times centimeters times centimeters, this would be centimeters cubed for volume. Okay, so that's kind of my 2 answers there. Highlight them there so they stick out. So what we're going to be looking at in this activity is we're going to find the surface area and the volume of some different cells and try to figure out why cells are small. That's the whole point of this. All right, so let's look at the next step. Background. The cell membrane is the gateway that lets food, oxygen, chemicals, and anything else the cell will need into the cell. It also pushes waste out that would be harmful to the cell. Okay, so the job of the cell membrane is to let good things in, get rid of the garbage. Think of the cell as a high school. The doors let things in and out of the school. If there are not enough doors, some students may have to wait in line to get inside. Okay, so you've seen this before when it's really busy and there's a big mob to get in that people have to wait. In that case, students might be late for class. During a fire drill, it would be difficult to get all the students out quickly and safely. Okay, and we've seen this too. When the building is full, when all the students are here, it takes a while to get everybody, especially like from the second floor, down the hall, down the steps, and safely outside. Okay, now if the school adds another floor of classrooms on top, so if we build the building up higher, but we do not add any more doors to get out, this problem is going to get worse. It's going to take a lot longer for people from the third floor to get down to second, to get down to first, to get out of the building. Okay, so that's what it would look like for a high school. Now, pretend that the school is a big cell. Okay, if the cell gets bigger, but we don't have enough doors to let things in and out, because remember, the cell membrane lets food, oxygen, chemicals, anything we need. It also pushes waste out. So if the cell gets bigger, but we don't add more membrane or more doors to let things in and out, what might happen? Okay, now I'm not going to give you a full answer here, but I'll give you a couple of ideas. You have to write an answer here. But do you think the cell is going to be healthy? Or do you think the cell might get sick? Do you think the cell might die? You might want to use food, oxygen, waste as part of your answer. Okay, so if you don't have enough cells, or I'm sorry, let me back up. If your cell membrane doesn't have enough doors, what's going to happen? Okay, so I'm not going to give you a full answer. You need to think about that. Fill it in. And I'm going to go to the next page, but feel free to pause the video if you need to. Okay. So here we have 3 boxes. We're going to pretend these are cells. And we are going to find and compare the surface area to volume ratio. In math, a ratio, sometimes you think of it as a fraction or dividing. So we're going to find the surface area, find the volume, and divide them like a fraction. Okay, a larger ratio means there is more surface area to support the cell's volume. So there's more doorways. And the cell can get materials inside and waste outside quickly enough so the cell stays healthy and in homeostasis. This word, homeo, means same. So the cell wants to be the same status, the same salt, the same water all the time. Now, if that ratio gets too small, waste can build up in the cell because it cannot leave fast enough. And if waste builds up, think about like your body. If you don't go to the bathroom often enough and that waste builds up, how do you feel? All right. So if you don't go to the bathroom for 3 days, you might be feeling pretty yucky. All right, so we need to find the surface area and the volume of these 3 cells. I am not going to do all the math for you, but I will start some math for you. Okay, now because these are cubes, every side is the same. Okay, so first we're going to find the area of one side. So this first cell here, if one side is 1, all the other sides are also going to be 1. So 1 times 1 equals 1. Okay, so that's pretty easy, right? Okay, now the middle cell here, if you have a side of 3, the surface area would be 9. And then this larger one, 10 times 10, will give us a surface area of one side of 100. Okay? Now all 6 sides are the same because these are cubes. So the front, the back, the top, the bottom, the left, and the right are all the same. So instead of figuring all out individually and adding them like we had to do on the front page, if I know one side is 1 centimeter cubed and I multiply it by 6, then my surface area is going to be 6 centimeters cubed, or squared, I'm sorry. Okay, this guy here, if it's 9, 6 sides, you can figure that out. Same thing with the bottom. Okay, so as you can see, as the boxes get bigger, the surface area is also going to get bigger. And that makes sense. If these were Christmas presents that you were wrapping, it's going to take more wrapping paper for this big one than the small one. Okay, if these were Christmas presents, it would take more wrapping paper for the big one than the small one. Okay, now volume, the length, the width, and height are the same because it's a cube. So this little box right here, 1 times 1 times 1. Okay, so 1 centimeter cubed. Now you don't have to show your work, you can just write the answer, that's fine. Okay, so for 3 times 3 times 3, so 3 times 3 is 9, 9 times 3 would be 27, and I'll let you do the last one. Okay, now the word ratio here, we're going to divide these. So my surface area number divided by the volume. So my surface area was 6. I'm going to divide it by my volume of 1. And my ratio is 1. And my ratio doesn't have units to it. It's just 1. Okay. So this guy down here, let's see. 9 times 6, 36. No, 54. Okay, so this would be 54 divided by 27, and that surface area to volume is 2. Okay, and then you can do the last one. So you can see that when the cells got bigger, their surface area to volume is also changing, right? What did it say about up here about that? A larger ratio means there's more surface area to support the volume, and the cell can get materials inside and waste outside quickly, so the cell stays healthy. Okay, so larger ratio is good. So which one of these has a larger ratio? Oh, dude. Mrs. Wentz screwing up in her video. 6 divided by 1 is 6. Silly Miss Went. All right. So out of these two, the one that has the larger ratio is this guy here. You're going to have to see this one down here and see what that is. Okay, but that tells me that if I compare these two cells, this one with the larger ratio, when I divide them, this one is going to be more healthy, and this one over here may not be as healthy. It may do fine, but it might be not as healthy because it might have waste building up inside or things like that. All right, so that's how we do that math. So you need to finish the math, and then you are going to answer these questions here. Okay, so I'm not going to help you with all the questions. I want you to think about that. Okay. I am going to show you a video clip of this in action. And this would be a really cool lab to do in class if we were all together and I had all the materials. So I'm going to kind of talk, I'm going to mute it and kind of talk through it. Okay. think we're going to have to do it this way to see the full screen, and that's okay. So what we have here is there's a little blocks of gelatin. So it's kind of squishy, and it's something that we use to grow bacteria on in the lab. And it has an indicator in it. So that's something that changes color. And this indicator is one that you used in physical science. It's called phenolphthalein. So it's bright pink. And it's soaked through the gelatin. And when phenolphthalein comes in contact with a base, it'll turn clear. Okay? And hey, there's some numbers there. Some of those might look familiar. So the same kind of math you just did, except you didn't have 1, 2, and 3. You had 1, 3, and 10 there. But she's kind of, the teacher's describing how the difference in surface areas work. So out of these cubes here, they are placed, we have 3 beakers. And you can see that we have a large cube, a medium cube, and a small cube. And the dimensions match her chart. So this is 1 centimeter, 2 centimeters, 3 centimeters. And they're going to put them in some base. And as the base soaks into the cube, you're going to start seeing a color change. The liquid on the outside, as it goes in, it will take the pink color away. All right, so let's kind of pause right here. So you can see here that the outside where it was touching the base, it has turned white. So as the base goes into these cubes, you can see the color change and see how far in it's gone. Okay, so you can see same thing here. So the outside is white, and same thing with this guy. Now, but if you think ahead, if we leave him for a while, this little guy here, he's going to be able to get rid of most of his pink. But these bigger cells are still going to have a big chunk in the inside that's too far away from the edges for that to get in and get rid of all that pink color. And that's kind of like the garbage inside of a cell. Okay, the cell membrane can get rid of the garbage close to the edge or close to the membrane, but if there's a big pile of stuff in the middle, it just kind of gets stuck there and poisons the cell. So cells that are smaller, all the parts are close to an edge and can push that garbage out. If the cell is bigger, the whole center part is not very close to an edge, and it's much harder to push out all of that garbage. So that's why cells have to be small, and this little demonstration kind of does a good job of showing that, of how chemicals from the outside can only get in so far before they kind of stop. And the same thing's going to be true for anything on the inside trying to leave. All right, so I wanted to show that to you as a little clip. Okay, now another example here, this is an animal called an amoeba. And we've watched some videos from the Amoeba Sisters. This is what they're kind of named after. So an amoeba is a one-celled creature, lives in lakes and ponds, and you can see that he's got lots of cell parts inside. He's got a nucleus and different things. But he's not a box shape. He's a squishy all over the place shape. And because of that, you can actually see that there's not many places that are far from the edge. Okay, so like right here, I only have to go that far to get to an edge to get rid of garbage. Right here, I can go to there. If I'm right here, pretty close, right? Right down here, still pretty close. Right in here, not too far from an edge, right? So every place, because of the shape, all the little ins and outs means there's no place that's very far from an edge. So this guy can get rid of garbage pretty easily. So those shapes do matter. All right. So this last part has you look at some different shapes. So instead of cubes, you're going to see, does this short fat shape or this long and skinny shape, which one is better which one has the lower and which one has the higher of these ratios of surface area to volume. Okay, so you'll do the math the same way you have been. You have an example from the front of how to do the math on these rectangles. And out of the two shapes, then compare which one should cells have to stay healthy. And then the last part here, we have a mitochondria. This is an organelle that does energy. And notice on the inside, it has a membrane shape that has lots of folds, lots of ins and outs. So there's not any one place that's really far from the edge. And the other thing that happens is on these folds, you have more chemical reactions. So you're able to fit lots of folds in a small area of space. Okay, so you have one question to think about with that. Okay. So that is our assignment here, our worksheet. Why are most cells small? So go ahead and finish up the math, finish up the questions, hand in when you're done. And as always, if you have any questions, please ask. Have a great day, guys.